Okay, this is the MPX SCC signal conditioning circuit, and really thanks, Alan. You're like this Santa Claus who made this happen, actually. Anyhow, it is the MPX 5100 AP connected to this board. You can also have a smaller footprint sensor, which you can mount on the back side here somewhere. There's pants for that. Anyhow, this sensor allows you to attach a nozzle to it. It's got a op-amp, which is amplifying the very small output from this sensor, small varying output, because it's supposed to be measuring the full span of the atmospheric pressure, and we only want a bit of it. So we calibrate that by the potentiometer, which is mounted here, 10-turn Burns potentiometer. We're changing that on the Baloo board to be automatic from the processor because it's got a digital to analog converter. And if you haven't calibrated it right, it goes to alt panic, which means you can't do altitude hold anymore, which is a safety feature, I think. And then you have a 3-pole Butterworth filter, which takes away all the energy of the frequencies above, I think, 10 Hertz, which is working in very effectively at 18 decibels per octave. And anyhow, there's an LC filter here, the inductor, which is powering it all, and then we have a 16-bit analog to digital converter, which we get 15-bit effective resolution from, because we're doing it in single-ended mode, not the differential mode. And also we have an I2C interface, those two yellow wires here. It's 2 lines of code, and it's quite effective. It's taken 2000 bytes, I think, to produce the code, to read this, and we're sampling in 860 Hertz, 860 samples per second in this little device, which is digitally filtering it, and then it goes through these wires here and into the I2C port, and we're sampling it in the Arduino on the mini board in 50 Hertz, and doing no software filtering in the Arduino, because that's handled both in this analog circuit and this AD converter. Yeah, and also I have hacked the USB FTDI cable to not include the USB power, because that's noisy. That's introducing quite a lot of noise, actually, which I can just see in the graphs made. So anyhow, this sensor is quite sensitive to how you mount it, this direction or this direction. So I'll try to be consistent in this test. It changes like half a meter or something in the static reading if you change the position of this. It's because the piezoresistive elements that's changing position. I think you get it with the BMP 0852. Anyhow, this is the graph. This is the sensor. I have it in auto. Yeah, that's better. In auto calibration or auto ranging mode. This is high and this is low. High and low. I'm changing it maybe a little more than half a meter right now. So it's pretty good statically. Of course, you get this little random walk noise drift, whatever, which you get with every barometer. So I'm starting to think that actually that's inherent to barometers or the air pressure. I don't know yet, because I have never tried a really super good one. But I think this is very good dynamically. Let's scale it up a bit. So now we're reading from a scale of about 1 meter. We're having it in the middle, yeah, fine. Upwards, very fast, it registers and it stays. Downwards, very fast, registers and it stays. Okay, let's make the auto scale go. Yep, holding it in the middle, and it's registering middle. Down very fast, registers that. Upwards, downwards. Now I'm doing it in half a meter amplitude, and yeah, pretty fast. So as you can see, this has got no problems registering fast movements, upwards, downwards, upwards, downwards. So I think it's very good for dynamic measuring of the altitude, which we can convert into vertical velocity, of course. Up, down, middle. Yeah. So you can also produce this nice little ringing curves like this, and then it stays in the middle. Up, down, up, down, up, down, up, down, and then it slowly stays in the middle. Up, down, down, half a meter about, and then it stays in the middle like this. So I think you can't reproduce this with the BMP 085 actually, because this is just too fast response, and response is what we need to control the quad. I know Alan is arguing that we don't need the Baro to do the dynamic things, but if we can, we don't have the accelerometer drift, which is also hard to tackle. Up, down, up, down, up, down, up, down, stays in the middle. Yeah. This is actually only 30 centimeters. And larger amplitude, 1 meter, or yeah, half a meter maybe, stays in the middle. Up, down, and stays in the middle. Slowly rings in. And also I have no kind of dampening device or foam or anything on the nozzle, so I think I'm getting this small little pitching tops, because the air is neutralizing in this element actually. But I'm happy, and yeah, thank you again, Alan, for giving me a chance.